in this tutorial we are going to learn about the pandas module. So pandas is nothing but a library to work upon data sets and two-dimensional data frames. So it helps in working on data frames. So basically in pandas we are going to create some data frames and we are going to work on it. So let us start with pandas. Similar to NumPy, we have to call pandas as pd, and we will also call NumPy as np. Why we are calling NumPy also? Because we are going to make use of NumPy and pandas both here and create data frames. We'll run it. Now both the things are imported. Let us create a series. So series is a pandas data structure used to store information in a form of sequence. So in order to create a series is a data frame which will hold the information in the form of a sequence. So s is equal to pd dot series, and inside it we can pass the values in the form of a list, comma 3, comma 4, 5, comma 2, comma 6, 4, 6. So these are values inside this series s. So we have created a series using pd dot series method, and these are all values inside the series. Let me create 2-digit values so that we get more clearer picture. So the value at the 0th index is 10, value at the first index is 30, second index is 50, and so on. So basically we can create a series like this. Now we can also use alphabets or letters to create a series. So we can create a series of alphabets like name is equal to pd dot series, and inside it will create a list of names. So let us put the name as A, second name as B, third name as C. In quotes we have to put, do not forget to put it in quotes. Then we have D, and then we have E and F. So name will give us the names, a series of names. Now in this series we are getting all the alphabets. So series with the values as alphabets or name has the data type object, and the series with the values as numbers in the form of integer has the data type integer. We can create a series of float data types also. Now let us create series using the random numbers. So we have to create a series of values. S is equal to pd dot series, and inside it we will pass the random number generator. So we have worked on it, how to generate random number. We'll generate the random numbers from 40 to 90, and we will generate 6 values. So let us create np dot random dot rand int. How many values we want? We want to create the values from 40 to 90, and we are going to create 6 values. So let us create 40, 90, 6, and we have to create indexes also. So indexes we will create in a range of 1 to 7 or 1 to 6. So index is equal to np dot a range 1 to 7. Why we are taking 1 to 7? Because it will skip the last value. Let us see s. So now the indexes, in the previous cases the indexes were starting from 0, and in our case the indexes are starting from 1 to 6 for the values 56, 87, 85, and so on. If I run this again and again, values are changing. So if you remember what we did to prevent this, we will simply write nb.random.seed. If you remember it, we did it in NumPy class. This will not let the values change. Seed we can put any value, test 23, 231, any value. If I put a constant seed value, it will not change. Can you see? The values are not changing. So now we have created a series with certain values which are random and which are not given by us. Now we can modify the series also, or modify the index of the series. So our indexes are 1 to 6. So suppose I want to modify the index in the form of alphabet. So to do that, what we will do, let us put s dot index is equal to, we have to simply pass a list of values. Let us put a comma, as we have 6 values or 6 values stored, so we have to pass 6 alphabets here. A comma b comma c comma d. Now we have 4 values, we need 2 more, a comma f. So now we are setting the indexes from 1 2 3 4 5 6 to a b c d e f. If I run this and if I run s, now the indexes which were earlier 1 to 6 are changed to a b c d e f. So this is how we can create indexes of our choice and modify the indexes. Now let us run, or let us create a series using a dictionary. So let us create a dictionary with values. As key value pair we will be taking, let us take key as, suppose, roll number of the student, and value as, suppose the value of the student roll number is 101, followed by name of the student. So let us put name of the student. What should be the name? Name, let me give Samuel, and let us take one more value as marks. Suppose these are the marks of the student. Let's say let the marks be 90. So this is a dictionary with few values as key value pair. Roll number is 101, name is Samuel, and the marks is 90. So we can create a series using a dictionary also. So let us run it, and we can create a series pd dot series dic. So this series has roll number as the first key, name as the second key, and marks as the third key. The object or the value of the series is object because it contains 2 numbers and 1 alphabetical value. Therefore, if any one value is alphabetical, it is going to throw us object data type. Now the use of this indexing, like we will learn how to see the index values or the values inside a series. Suppose you want the first element of the series, so S0 will give you the first value. We can use the alphabetical indexing also, as we have the value or the index value as a b c d. So if I put s of a, it is going to return the same value, which is nothing but the first value, alphabetical value. So 63 it is going to return. Suppose we want to find the first 5 values. For that we have to put 0 is to 5. So it will give us the first 5 value, which is a b c d e. Same we can do by using the alphabetical indexing. We want from a to e, so we can put a to e, and it is going to give all the values from a to e. So this is the use of indexing, based on which we can create or we can identify more records easily. Now we can also fetch the values based on condition inside a series. So suppose I want to fetch all the values inside the series as greater than all the values which are greater than 80 for say. So if I put it, I am getting false for all the value, but it is getting true for one value, which is at the index b. For index b, I am getting the value 88 true, and all other values are false, because 88 is the number which is greater than 80. Rest all other numbers are less than 80. So if you want to see which values are greater than 80, like which is the value, you can put s square bracket, and we are getting the value 88. Suppose you want to fetch the values from s greater than 80 or less than 80, value which is less than 80 and value which is greater than, say, 60. Greater than 60, let us take greater than 60. Let us see all the values. So we are getting 63, which is greater than 60 and less than 80. Let me take all the values which are less than 90 and greater than 60. So values which are less than 90 and greater than 60 are 63 and 88. Suppose I want to fetch the values which are greater than 50 but less than 90. So we are getting 4 values, which is 63, 88, 60 and 51. So this is how we can use series and we can fetch values in a series. Now we will learn something about pandas data frame. What is a data frame? So data frame is nothing but a method by which we can store the data, or a data structure which can help us to store the information in the form of row and column. So we will now create a pandas data frame, or we will use the pandas data frame. So let us create a pandas data frame first. So in order to create a pandas data frame, we use dictionary. Let us create a dictionary first of all. So dictionary, let us create a dic1 is equal to dictionary. Let us take the key as roll number. Roll numbers, let us take it as np dot random dot or np dot arrange. Let me take roll numbers from 1 to 100, 1 to 100 or 1 to 20, 1 to 21. Let us take roll number from 1 to 21, and after that let us take only 10 values. So 1 to 11, and then we will take names. Names to be in the square bracket. First name is A, second name is B. So basically we are going to put a lot of names. Actually, yeah. Actually, I'll manage the first space. We want to enter only the 10 values. So we have entered A, B, C, D, then E, F, G. Right, so how many values are there? 1, 2, 3, 4, 5, 6, 7, 8. We need 2 more values. I, and last value is J. So we have 10 roll numbers and 10 names. We can create marks also. So let us create marks using marks as another value inside this. Just a second. Marks as another value in this dictionary. Key, another key in the dictionary. So we can use random number np dot random dot rand, and hopefully this works, otherwise we have to create it using list. So np dot random dot rand, and we want to create marks from 30 to 40 or 30 to 89, and the values we have to create as 10 values we wanted. Let me see if it works. So basically it is working. Let us have a look at the dictionary dict1, how it looks. So this is a dictionary where the first key is roll number and the values are from 1 to 10. Second key is name and the values are from A to J. Third key is marks and the values are starting from 65, randomly distributed between 65 to 30 to 89. Before that, let us set a random seed. Let us take seed value 9. Now the values will not change again and again. We will use this value dic1 to create a data frame. So let us create a data frame as df is equal to pd dot data frame, and there we are going to pass the dictionary 1. And let us have a look at the df. We can see a beautiful tabular layout is formed with the values roll number 1 2 3 4 and so on, names abcdefg, marks, we can see the marks. So this particular arrangement of values are nothing but a data frame. Now we can do multiple operations on data frame. So here we are able to see all the values. Suppose we want to see the first 5 values, we can put df dot head. The first 5 values we can get. If we want to see the last 5 values, you can put df dot tail. It is giving us the last 5 values 6 7 8 9, 5 6 7 8 9 basically. You can specify how much values you want. You want the first 2 values, you can put 2 and you can get the 2 values. If you want first 3 values, you can put the last 3 values, you can put 3 and you can get the last 3 values. Now we will learn how to read the file or the data frame into CSV, or the CSV data frame into our system. So let us create a data frame df is equal to pd dot read underscore CSV. Now this file must be present inside the downloads or wherever this Jupyter notebook is actually. So right now my Jupyter notebook is in downloads. So the file that you are going to load or read should be always present in the download section. The file that we are going to read is a file named as dataset.csv. It is the same file we read in the numpy section. Let us read it, dataset.csv. We will run it and see what we are getting exactly. Are we able to read it or not? So yeah, we can see we are able to read the file. Now what does this file contain? There are a lot of information. We just want to see the first 5 values. We will put df.head. df.head is going to give us the first 5 values of this data frame. Now suppose we want to check the type of df, or what is the data frame values, or what exactly this data frame is all about. So we can put df.info to get all the information about the data frame df. So it is giving us serial number column. The name of the column is serial number and the values are non-null and integer. There are 400 values and there is no missing values. Therefore it is giving 400 non-null values. The data has 400 rows and 9 columns, and these are all the 9 columns ranging from 0 to 8. Now we can also try to extract the columns only. So if you want to know the columns only, we can put df.columns and it will return us the name of all the columns. Suppose we want to find the index values, we can simply put df.index and it is going to give us the index values. It is starting from 0 and ending at 400 by the step size of 1. Ideally it is 400, but it is going to take us 1 less value because the index is starting from 0. Now we can also find what is the type of the data frames or what information this data frame is actually holding. So there are 3 ways by which we can extract the information from this data frame df. So this is data frame df. If we want to see information from one column only, what we have to do, df square bracket, and we have to mention the name of the column into quotes. Df square bracket, suppose I want to see GRE scores, I'll take it, I'll paste it. Now I will get only the information of GRE scores, nothing else, only GRE scores. Similarly, if we want to see CGPA, we have to copy CGPA from here. We have to make sure that whatever data we are putting now, so the values or the name of the column should be as it is. There should be exact space as it is written. So if I put like this, if I run this, we are getting all the values. Suppose we want chance of admit. Now chance of admit, if we run this, let's see, if we run this, we are not getting any value. The reason being is chance of admit has a space after the name, so we have to copy that space. So if we don't put that space, it will give us error. So if I put this and if I run this, we are able to get all the chance of admit in that data. This is one of the way where that we used to fetch the data. We can use square bracket indexing also. If we put df square bracket all, we'll get all the values. If you want the first 10 values, we can put df square bracket first 10, and it is giving us the first 10 values. If we put the first 5 rows, so it is throwing us error because it is not able to recognize the first 5 rows using the square bracket, first 5 columns using the square bracket indexing. If we run this again we will get the same error. So in pandas data frame, we don't have the indexing in such a way. To do that, we have something special or a feature by which we can select the columns. So we have df.ilog and df.log. First we will explore df.log. So df.log is used to fetch the information based on multiple indexes. When I say multiple indexes, it means we are fetching the information based on rows as well as columns. So let us see how we can do it. So suppose I want to see 2 columns and all rows, and these 2 columns are nothing but LOR and CGPA. So suppose I want to see LOR and CGPA, all the values of LOR and CGPA. So we can do it so by putting the colons here and the name of the columns that we want to fetch in a list. So what are the names? LOR and CGPA. So that is in capital, so we have to convert it. CGPA. Wait, what is happening? CGPA. When I put it, so we are missing out on something. What is the key error? It is asking us LOR not in index. So LOR is not in index. Okay, is it LOR space? It is LOR space. So we have to put space also. LOR space. Now if we run it, it is giving all the values of LOR and the CGPA. Suppose I want to see the first 10 values, I can put like this. So these are the first 10 LOR and CGPA. If we want to see the last 10 or any CGPAs or the values, we have to put or mention the indexes of that CGPAs here as a list. Now we have understood how we can extract the information. We can use this indexing to find the information in a way that we can check for the values of a particular column and use that indexes to fetch the values. For example, someone asks us who are all the students whose TOEFL score or whose university rating is greater than 3. If someone asks us, how we'll find. So let us see the data. Okay, so data df is in small. So suppose we want to find all the students whose university rating is greater than 4. So if for that we'll put df square bracket university rating column. Let me take the column like this, paste it here, and university rating which is greater than 3. If I run this, so we are getting all the values of university rating which are greater than 3. Now we want to see which all columns are there. So for that we can put df square bracket open, square bracket close, and run it. So now we will get all the universities whose university ratings are greater than 3, or like all the student records where the university ratings are greater than 3. Now we can store this value in a list or in a variable greater than 3 equal to, and suppose someone asks us how many people are there whose university rating is greater than 3. So we can put greater than 3. We can find the length of greater than 3, basically length or len function, if you remember it, len. Let us see. So there are 134 records whose university rating is greater than 3. If we run np.size, let us see what we get on greater than 3. So we are getting 1206, which is 134 into 9 columns. 134 into 9. 1206. So basically when we run np.size, it is multiplying the number of rows and number of columns, and that is nothing but the size of that particular data frame. So this is how we can work on data frames in Excel, and CSV files we can import in data frames. Next is, now we will learn to extract a particular information or group the information in a certain type. For that we need to import some other data set. We'll import it. So I'll create the data frame in some variable df1 is equal to pd.read underscore. So the data that we are going to read is in the form of an CSV file. So we will use read underscore CSV function. Inside it we have to pass the name, that is market.csv, and then we will run df1. So basically here we are able to get the data of market and the store sales. So we have data for Jan, Feb, like for till May we have. Now what we can do, if we want to summarize the data with respect to month, so we can do one thing. We can use df.sort underscore values to sort the data set. So let us sort the data set based on the sales done. My bad, I did something wrong. Let me remove this. So so let us run it. df1.sort underscore values based on what we want to sort it. So based on we want to sort it based on sales. So we will put the sales value, and we want it in ascending order or descending order. So let us take it in ascending order first, and then we'll explore the descending orders. If I put like this, so we are sorting the sales data in the ascending order. You can see the indexes are also changing because we are sorting or arranging the data in the form of ascending order of sales. In order to put or show it in descending order, we have to put ascending is equal to false. If we put ascending equal to false, the data will be sorted in the descending order. So this is the only difference used to sort the data in ascending or descending order. We can also add more information to the data. For example, we want to add the information of one more month, that is June. So in our data we have information till May, I guess, and we want to add information of June. So let us see how we can do it. So to find the information of or add the information of one more month, so df, so let us create the data first. So first of all, the data is all about month, store and sales. So we'll create a dictionary that will have month, store and sale. Dict2 is equal to dictionary, and first is month, and we want the month to be June. So let us put June. So we want it to be done multiple times, so we'll copy this at least 4 times. 1 2 3 4, and we have created a column called as month in a dictionary, month, and followed by store. So we want store now. Store, we will put here stores as randomly between A, B, C. So I'm taking it properly because I don't want any mistake at the end. So how many values? 1 2 3 4 5. So A, B, C and D and E. So we have taken the elements. Now we want the sales value. So let us take it as randomly 5 values will take between 20,000 to 40,000. So sales, we will take np dot random dot rand int how many values? 20,000 to 40,000. We want 5 values. Let us have a look at dict2 now. Okay, something is missing. A, B, C, D, E. Store, sales, one comma is missing, right? So one comma was missing. Maybe that was the reason we got the error. If we run again, there is something missing, which is one more comma. Now we have created dictionary successfully, which has 5 values of June month. So we want to add this information in our existing data frame df. In order to add it, we can use the append method. So append method will help us to create. So first of all, we have to create this new data, new df1 is equal to pd dot data frame, and the value is nothing but dict2, which is new df1. So we have 5 values inside this new dictionary. Now, as I told, we are going to add these values to our existing data frame df. In order to add it, we have to use the append method. So df, so we are going to reassign df to df. Df is equal to df dot append, and we are going to append what? We are going to append the value df under df new df1 to it. We'll append it, and after appending, we are going to put ignore index is equal to true. Ignore underscore index, ignore index is equal to true. When we set ignore index is equal to true, let us see what happens. Okay, let us see df. So we have, okay, so we have inserted, alright, so we are making some mistake. So we wanted to insert it into the df1. I have mistakenly used the df. So let us see, and let us see this. So in our df1 we are adding, we had data till May. If you look at the previous values, we had data till May. We wanted to add this new information of June month, so we have added this in this using this append method. And ignore index is true will set the indexes as, it will avoid the names that we are have in this two data frames. So indexes, or it will also ignore the indexes that are going to give. For example, from here onwards it would have taken 0 1 2 3 4. So ignore index will forward or extend the already existing indexes from the new or the old data frames. So we can see the values are new. If we want to see how many times the months are repeated, how many months, which month is repeated how many times, so we can do it by df1 dot value underscore counts. Value underscore counts will count how many times the values are getting repeated. So df1 square bracket, we have to mention the column name. So column name we have to use as month. Suppose how many times months are getting repeated here. So each month is getting repeated 5 times. Let us take store, or let us see how many times the stores are getting repeated. So each store is getting repeated 6 times. Now let us find the aggregated values of the sum of sales per month. So sum of sales per month, for that we use df1 dot group by. Group by function will group by the data and give us the sum of sales with respect to the groups that we are creating. So we are going to create this groups with respect to month, and here we are going to put sales, and we are going to count, or we want sum. So for sum we will use sum. So we can see the sum of sales with respect to month. If you want to sort it, we can also sort it by putting dot sort underscore values with respect to sales. and ascending is equal to false in order to see the highest value. Ascending equal to false. So we are sorting the data, so we can see that month of May has the highest sales or the highest total sales. If we want to see the highest average sales, it is the total sales, which is nothing but by taking the sum of the sales of every month. So we can see if we add the month of March, so the total sale of March is 175169. If we add the total sums of May, so it is 2 lakh something around that. If we want the average value, we can put here mean. So we are getting the May as the month where we have highest number of sales with respect to mean also. So we can find any possible values if you want to find the highest sale per month. So we can use max. So in the month of March there was highest sale happening, and if we want to see minimum sales per month, and we have to put ascending as equal to true. So Jan is the month in which we had the minimum sale, which is 20,722. So this is how we can use group by to aggregate the whole information of the data.